In this video, I am going to discuss the problems from exercise 13.2 of NCERT textbook, that is of the derivatives. Before I start solving the problems from the exercise, let us revise some basic formulas of derivatives. So starting with the first principle of derivative. So what is the first principle of derivative? So if you have a function f of x, then the differentiation of f of x is nothing but differentiation of f of x with respect to x is equal to limit h tends to 0, limit h tends to 0, f of x plus h minus f of x by h. Right? This we also denote by f prime x. F prime x means the differentiation of f of x with respect to x. Right? We have already discussed about the limits that in exercise 13.1. Now you are able to get the limits of any functions over here. Right? Now coming to the second one. So algebraic functions of derivatives, that is, if you have dy by dx of two functions which are either additions or subtractions, f of x plus or minus g of x can be written as d by dx of f of x plus or minus d by dx of g of x. So we can differentiate them individually. Similarly, if you have d by dx of f of x into gx, then we use the product rule. What is the product rule? First we differentiate f of x and multiplied by g of x, that is f dash x, plus, and then we differentiate g of x multiplied by f of x, so that g prime x. So this is called product rule. Now when we come across the problems of d by dx of f of x by g of x, then we use quotient rule. What is the quotient rule? It says that we have g of x into f prime x minus f of x into g prime x, that is the derivative of g of x whole divided by g of x whole square. This is called quotient rule. So generally the students are known about this product and quotient rule in terms of u and v. If u is equal to f of x, there are two functions u and v which are the functions of x, then so the d by dx of uv can be written as so u dash v plus v dash u. Similarly, the d by dx of u by v can be written as u prime v minus v prime u by u square. Right? These are known to be product and quotient rules. Right? So mainly we are going to use these basic operations and the first principle. And let me give you a few more derivatives, that is, so d by dx of the derivative of x to the power n with respect to x is equal to n into x to the power n minus 1. So n, we take it as n times x to the power n minus 1. Right? For example, if you have d by dx x cube, it is nothing but 3 into x to the power 3 minus 1. That is equal to 3 into x square. Right? Suppose if you have d by dx of 2x to the power 5. So d by dx of 2x to the power 5 is 5 into 2 into x to the power 5 minus 1. That is 10 to the power 10 into x to the power 4. Similarly, whenever you have a constant, either multiplied by a function or divided by a function that we can write as d by dx of f of x. That's it. Okay, so d by dx of f of x multiplied by k. So the same thing is applicable for any number which is in the denominator. Suppose d by dx of f of x by k, where k is any real number, then we can write as 1 by k into f prime x. F prime x is nothing but derivative of f of x. Okay, so if we take the constant, if you have d by dx of any constant, any number, that is always equal to 0. d by dx of any constant is always equal to 0. Derivative of any constant is 0. So constants won't change with respect to x, so that they will be equal to 0. Now let me tell you the derivatives of some basic trigonometric ratios. I am not going to discuss inverse trigonometric functions in this session. So d by dx of sin x is equal to cos x, or d by dx of cos x is equal to minus sin x, and d by dx of tan x is equal to secant square x. Right? So from this, you'll be able to remember, if we take d by dx of cot x will be equal to minus cosecant square x, and d by dx of secant x is tan square x. Sorry, it is secant x tan x. We can write it as secant x tan x. And d by dx of cosecant x is minus cosecant x cot x. Right? They are some basic trigonometry function that we are going to use. So if you know about these three slides, you can see here we have discussed about first principle of derivative, and then algebraic functions of differentiation derivatives. That is, when you have f of x plus g of x, then we can do derivatives of f of x and g of x individually, and we can add them. When you have the subtraction also, the same principle is applicable, and this is known as the product rule. By using the product rule, we can do the functions which are multiplied with each other, and this is known as quotient rule. We can use this rule when we come across the functions which are in division. Okay, now let's start. Yes, let's see this. So when we have find the derivative of d by dx of x square by 2. So as we have seen, we have two terms here. So two terms can be written individually: d by dx of x square minus d by dx of 2. What is d by dx of x square? It is 2x minus 0, which is equal to 2x. Right? So at x is equal to 10, so we have to substitute x with 10, that's it. So at x is equal to 10, then this derivative 2x is equal to 2 into 10, which is equal to 20. That is our answer. Right? So here what we have used d by dx of x to the power n, where n into x power n minus 1. Right? X square is nothing but 2 into x to the power 2 minus 1. That will give us 2x. So from this we'll get it. Now let's see the second one. The second one is find the derivative of x at x is equal to 1. What is the derivative of x? d by dx of x is equal to 1. So at any value of x, it is always 1. At x is equal to 1, the d by dx of x is also equal to 1. So that means when there is no variable in the derivative function, then irrespective of the x value, that remains this constant. Even though at x is equal to 100 also, Even though you take at x is equal to some 50, so it remains same. d by dx of x is 1 only. Right? You can take x equals to 150, 120, 130, any number. Irrespective of that, it remains constant because on the right hand side, we do not have any variables, right? Now let's see the third one. Find the derivative of 99x at x is equal to 100. So, let's see that d by dx of 99x, which is equal to, so 99 can be taken out of the differentiation. So d by dx of x, it is nothing but 99 into 1, which is equal to 99. Again, we got the constant. So irrespective of the value of x, it is always 99. d by dx of 99x is always 99 only, irrespective of the x value. Now let's see the fourth one. Find the derivative of the following function from the first principles. So we have to use the first principles here. So what is the formula for the first principles? If you want to find out f prime x, that is d by dx of f of x, so what to write? Limit h tends to 0, f of x plus h minus f of x by h. So for the first problem, what is that? D by dx, f of x is x cube minus 27, right? F of x is x cube minus 27. Then what to write here? Limit h tends to 0, right? Here in place of x, so we have taken x plus h. That means in place of x here also you have to take x plus h whole cube minus 27 minus f of x is normal. So that is x cube minus 27. This is f of x whole divided by h. I hope it is clear. So wherever you have x, that you have to replace with x plus h as one function, and we have to write f of x as it is as the second term. So we have written here f of x as it is, and here we have replaced x with x plus h. We have to replace x with x plus h, and we have to write here. You will get this, right? Now let us simplify it. You will get limit h tends to 0. So we will have x cube plus h cube plus 3x square plus 3x square h. Just a plus b whole cube minus 27 minus x cube minus 27 by h. So x cube get cancelled, 27 get cancelled, right? So that we are left with h cube plus 3hx square. So we are left with limit h tends to 0, h cube plus h cube plus plus 3xh square plus 3x square h. Right? Now let us take h common here. When we take h common, we will get so h square plus 3xh plus 3x square whole divided by h get cancelled. Now let us substitute h is equal to 0 in this equation. We will get 0 plus 3x square. So that the answer is 3x square for the first one. Now let us see it for the second one. So for the second one, by using the first principles, so what is the function here? F of x is x minus 1 into x minus 2. Let us simplify it. So x square minus 3x plus 2, right? So now what is f prime x? By using first principles, it gives us limit h tends to 0. So wherever we have x, so we have to replace with x plus h whole square minus 3 into x plus h plus 2 is the first term, f of x plus h minus f of x. F of x is as it is, x square minus 3x plus 2 the whole divided by h. Now let us simplify this. So on simplifying it, what we get, x plus h whole square is x square plus So limit h tends to 0, x square plus h square plus 2hx, right? And then minus 3x minus 3h minus 3x minus 3h plus 2. Right? This is what we have on simplifying the first brackets. Now the second brackets, let us write as it is. X square minus 3x plus 2 minus 3x plus 2 whole divided by x. H. So limit h tends to 0. So x square get cancelled here. 3x get cancelled. 2 get cancelled. Right? So which is h square plus 2hx minus 3h by here. Can we take h common here? Yes, of course. Limit h tends to 0. When we take h common, we will have h plus 2x minus 3 by h get cancelled. Now substitute the h value in the limits in the given function, that is 0 plus 2x minus 3. So that which is equal to 2x minus 3. Right? So this is the derivative of x cube minus 27. So x minus 1 into x minus 2. Now let's see the third part of the fourth one. So now the given function here is f of x is 1 by x square. So we know that f prime x is limit h tends to 0. Right? F of x plus h. What is f of x plus h here? 1 by x plus h whole square minus f of x is as it is 1 by x square whole divided by h. So let us simplify it. So let us take the LCM in the numerator. So for this whole numerator value, so that we'll get x square minus x plus h whole square whole divided by, I can take it here h into x plus h whole square into x square. Right? So now let us write it as, let us simplify it. Limit h tends to 0, x square minus x square plus h square plus 2hx by whole divided by h into x plus h whole square into x square. So x square get cancelled here. So we get out here minus h square minus 2hx by h into x plus h whole square. This limit will be there everywhere, okay? Though I don't write it here, the limit comes. H tends to 0. Let us take h common here. So when we take h common, we will have minus h minus 2x by h into x plus h whole square into x square. So h will cancel. That's it. The problem is over. Now substitute h value. When you substitute h value, minus 0 minus 2x by x plus 0 whole square into x square. It will give us minus 2x by x to the power 4, which gives us minus 2 by x cube. That is the value of derivative of 1 by x square. Now let us take the fourth one. This is here f of x is x plus 1 by x minus 1. Right? What is the f prime x here? F prime x is limit h tends to 0. Limit h tends to 0. F of x plus h, right? Let us write it as x plus h plus 1. Wherever you have to replace x with x plus h. X plus h minus 1. Minus x plus 1 by x minus 1 whole divided by h. Okay, f of x plus h minus f of x. Right? Now let us take the LCM here. So to simplify the numerator value, when you take the LCM, h tends to 0. So we will have x plus h plus 1 into x minus 1 minus x plus 1 into x plus h minus 1 the whole divided by h into x plus h minus 1 into x minus 1. Right? Now let us multiply these two functions and these two functions. Right? So on multiplying, what do we get? Limit h tends to 0. So we have x square minus x plus hx minus h plus x minus 1. That is what we get when we multiply these two. X into x, x square, x into minus 1 minus x, h into x, hx, h into minus 1 minus h, 1 into x, x, 1 into minus 1 minus 1 minus. So now x into x is x square plus x into h is xh minus x. Now plus 1 into x is plus x, plus 1 into plus h is plus h, plus 1 into minus 1 is minus 1. So the whole divided by h into x plus h minus 1 into x minus 1. Right? Now let us try to simplify it. Here x get cancelled. This x square, this x will get cancelled. Minus x plus x will get cancelled. Anything else? Hx also will get cancelled. Right? So we are left with, I think minus 1 get cancelled. So now we are left with minus h, minus of plus h is minus h. So that they will not get cancelled. So what we'll have is limit h tends to 0 minus 2h whole divided by h into x plus h minus 1 into x minus 1. So this h get cancelled here. So now let us substitute the values of h here. So x plus 0 minus 1 into x minus 1. This is nothing but x minus 1 into x minus 1. Therefore, the value is minus 2 by x minus 1 whole square. That's it. Right? That is the derivative of x plus 1 by x minus 1. Now let us go to the next problem. So for the function f of x equals to x to the power 100 by 100 plus x to the power 99 by 99 plus and so on plus x plus 1. Prove that f prime 1 is equal to 100 times f prime 0. First let us try to find out what is f prime x for this. See, we can write it as 100 into x to the power 100 minus 1. This 100 is as it is. Okay, constants we do not we don't do differentiation when constants are multiplied by any other functions. So 99 into x to the power 99 minus 1 by 99 plus and so on up to x square, that is 2 into x to the power 2 minus 1 by 2 plus x is just 1 plus 1 is 0. When you differentiate x, you will get 1. When you differentiate the 1, you will get the 0, because when you differentiate a constant, that is 0. So this get cancelled, this get cancelled, this. So what we are left with? So we are left with x to the power 99 plus x to the power 98 plus x to the power 97 and so on. We'll go up to x plus 1. Right? This is what f prime x is. Right? Now let us see, to prove this, f prime 1 is equal to 100 f prime 2 prime 0. So let us take first f prime 1. What is f prime 1 here? Let us take f prime 1. What does it mean? We have to replace x with 1 to the power 99 plus 1 to the power 98 plus 1 to the power 97 and so on. Right? 1 plus 1. When you replace x with 1, we'll get total how many terms you'll get? See, 99, 98, 97 up to 1, we have 99 terms. This is the 100 term. This last one is the 100 term. So total we get 100 ones here, because 1 plus 1 plus 1 plus 1 to the power anything is always equal to 1 except 0, including 0, right? Which is equal to 100. F prime x is 100. Now let us see what is 100 f prime 0. Okay, what is f prime 0? We'll see that. F prime 0 is, this is f prime 1. Right? F prime 0 is 0 plus 0 plus 0. Anything power 0 is 0 until 0 plus 1. We'll get 1 here. So what is 100 prime 0? Therefore 100 into f prime 0 is equal to 100 into 1, which is equal to 100. That's it. Right? So that f prime 1 is equal to 100 prime 0. Hence proved. Therefore, f prime 1 is equal to 100 into f prime 0. Now let's see this sixth one. Find the derivative of x to the power n plus a to the power x n minus 1 plus and so on for some fixed real number a. This one is very easy, right? So if we take it as f of x, what is f of x? X to the power n plus a into x to the power n minus 1 plus a square into x to the power n minus 2 and so on, a to the power n minus 1 into x plus a to the power n. Right? Now what is f prime x? Let's see. F prime x is equal to n into x power n minus 1 plus a into n minus 1 x power n minus 2 plus, right? I'm just doing directly. I hope you can understand. Just by using x to the power n formula. Okay, n into x to the power n minus 1 here. And the same here. A is constant. And then x to the power n minus 1. n minus 1 into n minus 1 minus 1. Okay, plus a square into n minus 2 x to the power n minus 2 minus 1 and so on. If we do it for the last two terms, we will get a to the power n minus 1 into 1 into x to the power 1 minus 1 plus a to the power n is 0. So that we can write it as n into x to the power n minus 1 plus n minus 1 into a into x to the power n minus 2 and so on. Okay, we will go up to the last term. What is the last term? A power n minus 1 into x. Okay, we will have a square, a cube and so on, a to the power n minus 1 into x. So this is the answer for this question. Now let's see the seventh one. For some constants a and b, find the derivative of x minus a into x minus b, ax square plus b whole square, x minus a by x minus b. So let us start with the first one. So let us simplify it first. Let us say that f of x is equal to x minus a into x minus b. On simplifying this, what do you get? X square minus bx minus ax plus ab. So now it is easy, right? Then the derivative of it is nothing but x square. It will be 2x minus b minus a plus 0. So the value is 2x minus a minus b. That is the answer. Right? Now let us take the second one. So let us simplify the second one also first before we start solving. Let us simplify it. Ax square plus b whole square. It is a plus b whole square form, right? So ax square whole square plus b square plus 2ab. 2ax square into b. So what do you get here? A square into x to the power 4 plus b square plus 2ab into x square. Now it is easy to differentiate. So now if it is f of x, if we take it as f of x, what is the derivative of f of x? A square into 4 into x to the power 4 minus 1. B square is 0 because it is a constant, right? For some constant a and b it is given, right? So 2ab into, for x square it is 2 into x to the power 2 minus 1, right? So we will get, so the final value as a square into, that is 4a square x cube, and 2 into 2 4, 4ab x. Okay, so this is 4a square x cube plus 4ab x. Now let's see the third one, x minus a, x minus b. So for x minus a, x minus b, we can use the quotient rule, right? Let us use that. So if you have the f of x and g of x, what is the quotient rule? If you know that, if you have f of x by g of x, quotient rule says that f prime x into g of x minus g prime x into f of x, right, by f of g of x whole square, or you can write in terms of u and v also. So what we get? F prime x is, so f prime x is that is x minus a, right? The derivative of x minus a, can I write like that? Yes, let me write it. One more step, d by dx of x minus a into x minus b. I mean, we have to get x minus b into x, d by dx into x minus a minus f of x is x minus a and d by dx of x minus b. The whole divided by x minus b whole square. Right? So now this is equal to x minus b into what is d by dx of x minus a? D by dx of x is 1 minus a is 0 and x minus a into d by dx of x minus b is x is 1 minus 0 by x minus b whole square. Right? So we can write this another term. This is minus, right? Not plus, minus. So now, so we can see here this is x minus b minus x plus a by x minus b whole square. So x get cancelled. So what is the final answer? A minus b by x minus b whole square is the derivative of x minus a by x minus b. Right? Now let us see this. Find the derivative of x to the power n minus a to the power n by x minus a. So what is the function here? F of x is, let's say that f of x is, I think we have two functions here, right? Maybe we can take like that, similar to the previous problem. Let us take it that way. That is d by dx of x power n minus a power n by x minus a. Right? Now what we have to do? So we have to take x minus a into d by dx of x power n minus a power n minus x power n minus a power n into d by dx of x minus a, right, by x minus a whole square by using the quotient rule, right? G of x whole square. So now, which is equal to, what is x minus a? D by dx of x to the power n is, so I can take it as n into x to the power n minus 1. So a is a constant, so that it is 0. A power n is d by dx of a power n is 0 minus, so x to the power n minus a to the power n into d by dx of x is 1 minus 0. Then divided by x minus a whole square. Let us simplify it. We have x minus a into n into x to the power n minus 1, right? And here we have xn minus a to the power n. Now let's simplify it. So on simplifying it, we will get, so x into n into x to the power n minus 1 minus a into n into x to the power n minus 1, just multiplying x with this, a with this. So minus x power n plus a power n. Minus of x power n is minus x power n. Minus of minus a power n is plus a power n. So this is x minus a whole square. That's it. This is our answer. Maybe if you can simplify something, you can do. See this x into x power n minus 1. What is x into x power n minus 1? I can write it as x into x power n minus 1 is nothing but, here power is 1. So we know that when you have the same basis, powers can be added, n minus 1 plus 1. So that this is get cancelled, we get x to the power n. So that n into x to the power n minus an x to the power n minus 1 minus x to the power n plus a to the power n whole divided by x minus a whole square. This is the derivative of this. Now let's go to the next one. Find the derivative of 2x minus 3 by 4. Pretty easy, right? Nothing to do. D by dx of 2x minus 3 by 4. So first take the derivative of 2x and then take the derivative of 3 by 4. What is the derivative of 2x? It is 2. Derivative of 3 by 4 is 0. It is 2. Right? Now let us see the second one. So before we start solving it, let us simplify it. Okay. So first let me simplify it. What we get on simplifying it, we will get 5x to the power 4 plus 3x square minus x minus 5x cube minus 3x plus 1. 5x to the power 4 minus 5x cube, right? We'll get plus 3x square minus 3x minus x is minus 4x plus 1. Right? We have got all. So x to the power 4 and then x cube and then x square. Right? Yes, we have all. Right? Now this is simplified form. So that d by dx of 5x to the power 4 minus 5x cube plus 3x square minus 4x plus 1. Okay, so now it can be simplified as, so each term we can take it as 5 into 4 into x to the power 4 minus 1 is the first derivative. And then when you take the second term, 5 into 3 into x to the power 3 minus 1 is the second term. 3 into 2 into x to the power 2 minus 1 is the third term. Minus 4 into x minus 1 is the this one. And then 0. Right? So 5 into 4 is 20 x cube. 5 into 3 is 15 x square. 3 into 2 is 6 x to the power 2 minus 1 is x to the power 1 minus 4. This is the derivative of this second problem. I hope it is clear. Yes, let's go to the next one. This third one also similar to the previous one. So let us multiply this x power minus 3 with two terms inside the brackets. We will get 5 into x power minus 3 plus 3 into 3x into x power minus 3. So here we have 1, so we can add them. 5x power minus 3 plus 3x minus 2, minus 3 plus 1. Okay, minus 2. So now let us take the differentiation of it. D by dx of 5x power minus 3 plus 3x power minus 2, which is equal to, as usual, 5 into minus 3, n into x power n minus 1, right? D by dx of x to the power n is n into x to the power n minus 1. So n we have taken minus 3, so that x power minus 3 minus 1 plus 3 into minus 2 into x to the power minus 2 minus 1. So what do you get? Minus 15 x to the power minus 4 minus 6 x to the power minus 3 is your answer. Right? Now let's see the fourth one. So d by dx of x power 5 into 3 minus. So can I take the simplified form directly? I hope we can do it now. So x power 5 into 3 is 3x power 5 minus x power 5 into 6x power minus 9 is 6x power minus 4. Because x power minus 9 into x power 5 is x power 5 plus minus 9, that will give you minus 4. That's it, the problem is over. 3 into 5 into x to the power 5 minus 1. Right? We have to do differentiate for x power 5 and then x to the power 4 minus 4. Minus 6 into minus 4 into x to the power minus 4 minus 1. Now what do you have? 15 x power 4 minus 6 into minus 4 is plus 24 x to the power minus 5. This is the answer for the fourth one. Now let's see the fifth one. Right, x to the power 4 into 3 minus 4 x to the power 5. So you can simplify it and differentiate this. So what do you get on simplifying? 3x to the power 4 minus 4x to the power 9. X to the power 5 into x to the power 4 is x to the power 5 plus 4, 9. Right? That's it, the problem is over. 3 into 4 into x to the power 4 minus 1 minus 4 into 9 into x to the power 9 minus 1. Take the powers, multiply them with the quotients and take the 1 minus power, 1 less power. So that will give you 12x cube minus 36x to the power 8. That's it. Now let's see the sixth one. What is the sixth one? 2 by x plus 1 minus x square by 3x minus 1. So now let us take this. So we have d by dx of 2 by x plus 1. So can we take them as d by dx of 2 by x plus 1 minus d by dx of x square by 3x minus 1. Now we can use the quotient formula here, right? So what is that? So first we have to take d by dx of 2. Can I write it as 2 prime? 2 prime into x plus 1 minus x plus 1 prime, that is d by dx of x plus 1 into 2 whole divided by x plus 1 whole square, right? Minus, so x square prime d by dx of x square into 3x minus 1 minus 3x minus 1 prime into x square by 3x minus 1 whole square. Now let us take the derivatives of it. 2 derivative 0. So I can write as 0 into x plus 1 right? I can write it as 2 derivative as 0. So 0 into x plus 1, that is 0 into x plus 1, and x plus 1 derivative is 1 plus 0 into 2 by x plus 1 whole square minus x square derivative is 2x, 3x minus 1 minus 3x minus 1 derivative is 3 minus 0 into x square whole divided by 3x minus 1 whole square, right? Now on simplifying this, what we'll get? We will have x minus 2, right? X plus 1 into 0, x plus 1 into 0 is 0, so that we'll have only minus 2, right? We'll have only minus 2 by x plus 1 whole square. See the first term derivative, minus 2x into 3x is 6x square minus 1 minus 3x square, right? Can I take it as directly 3x square minus, let me write one more step. So 6x square minus 2x minus 3x square by 3x minus 1 whole square, which is equal to minus 2 by x plus 1 whole square minus 3x square minus 2x by 3x minus 1 whole square. This is our answer. Yes, right? Now let's see the next question. Find the derivative of cos x from the first principle. Again we have to go back to first principle, that is when we have d by dx of f of x. So what we have to write? F of x plus h, limit h tends to 0. F of x plus h is nothing but cos of x plus h minus f of x, that is cos x, right? So by h. Okay, so you can go back. So you can go back to see what is the formula for first derivative. F of x plus h, where x we have to write it as x plus h minus f of x by h. Now we know that, right? What is cos a plus b? You know the formula. Cos a plus b is nothing but cos a cos b minus sin a sin b, right? So now let us try to expand it. Why we are trying to expand it here is, so it will be, you'll get a simplified form of it, so that we can easily get the limit value of it, right? So otherwise, if you substitute h is equal to 0, it will be 0 by 0 form. Okay, so 0 by 0 form is not acceptable, so we are trying to simplify it. So I am writing it cos x into cos h minus sin x into sin h minus cos x by whatever by h, right? So what I will do is, I will take all the cos x terms one side, okay, and I will take sin x, sin h as one term. Okay, we'll take this as one term. So let us write. So limit h tends to 0. So cos x, cos h minus cos x. So I can write as cos x into cos h minus 1 by h, right? So minus. So let us write it as limit h tends to 0 sin x sin h by h. So here sin x is constant, right? Sin x is a constant, here cos x is a constant. So let us take them out. So cos x into limit h tends to 0 and cos h minus 1 by h minus sin x into limit h tends to 0 sin h by h. So we know that, right? This limit h tends to 0 cos h minus 1 by h is 0. This is equal to 0, right? We have seen in the limit section, right? And this is equal to 1, right? So 0 into cos x is 0 minus of sin x, that will give us minus sin x. So the derivative of cos x is minus sin x, right? Yes. Let's see the next question. So find the derivative of the following function. Yes, let us do it quickly. Just very much fast. Let's see that d by dx of sin x cos x. This is the product rule, right? F of x, g of x. So first take the derivative of first one, sin x prime into cos x plus cos x prime into sin x. So differentiate sin x into cos x plus differentiate cos x into sin x. What is derivative of sin x? Cos x into cos x, right? And what is the cos x differentiation? Minus sin x into sin x. So the answer is cos square x minus sin square x, right? This we can write as cos 2x also. This is also equal to cos 2x. Now let's see the second one. So second one is secant x. So what is d by dx of secant x? D by dx of secant x we have written in the starting slides, right? So d by dx of secant x is secant x tan x, right? Now let's take the third one. Third one is 5 secant x d by dx of 5 secant x plus 4 cos x. So we know that 5 cannot be differentiated. We take 5 out of the differentiation. Secant x is secant x tan x plus 4 cos x. Cos x differentiation is sin x minus sin x. That's it. This is the answer for third one. Let's see the fourth one. D by dx of cosecant x. What is d by dx of cosecant x? Which is minus cosecant x cot x. Minus cosecant x cot x. So fifth one, d by dx of 3 cot x plus 5 cosecant x. So 3 cot x becomes 3 into minus cosecant square x. So that I will take it as minus 3 cosecant square x plus 5 cosecant x. Cosecant x becomes minus 5 cosecant x cot x. Right? This is the answer for this. Now, sixth one. What is the sixth one? D by dx of 5 sin x minus 6 cos x plus 7. 5 sin x. Sin x we know, 5 cos x. Sin x becomes cos x minus cos x becomes minus sin x. So the minus into minus plus 6 sin x and 7 is 0. Right? Now, the last but not least, 2 tan x minus 7 secant x. So d by dx of 2 tan x minus 7 secant x is equal to, what is tan x? So differentiation of tan x is secant square x, 2 into secant square x minus secant x is minus 7 secant x tan x. Right? So that's it. Right? So we have done all the problems from exercise 13.2. Right? I hope you have understood all the problems, all the solutions. Right? So if you like this video, share it with your friends and spread the knowledge. And you can comment on the comment box to get the class material of it, the notes of it. Thank you. You can share your Gmail ID or any email ID so that I can share the notes of the session. Thank you.